Welcome back to the Dargslan series, part 18, and this one's about scripts that quietly lie to you. We're picking up where the first shell scripting installment left off, but shifting gears from does it run to can I trust it at 3 in the morning when it's running unattended? Over the next 16 slides, we'll turn casual bash into something production grade, starting with one tiny line. Set euo pipefail. Here's the roadmap. We'll start with why bash scripts lie to you by default, then meet the one-line fix. Set euo pipefail. That flips the language into something safer. From there, we'll talk about exit codes as the truth your scripts owe their callers, traps for guaranteed cleanup, dry run flags so you can look before you leap, and finally, idempotency. The quiet superpower that lets you rerun a script without holding your breath. So let's start with the betrayal. Picture this script. You cd into hashta amp build, then run rm rf star. Looks harmless, right? But if that cd fails, maybe the directory doesn't exist. Maybe there's a typo. Bash just shrugs and moves on to the next line, which means rf now runs wherever you happen to be standing. People have wiped home directories this way. Real outages, real data loss, from a script that exited with status 0 like nothing was wrong. The fix is one line at the top of your script. Set euo pipefail. 4 flags doing 4 jobs. The I makes any failing command halt the script immediately. No more silent marching forward. The U turns referencing an unset variable into an error. So a typo like home instead of home actually gets caught instead of expanding to nothing. And a pipefail makes pipelines honest. If any stage in a chained command fails, the whole pipeline fails. Bonus tip. When you're debugging, drop in set x temporarily and bash will print every command as it runs. Now, how does bash actually know a command failed? Through exit codes. Every command returns a number when it finishes. And the protocol is dead simple. 0 means success. Anything else means failure. You can peek at the last command's exit code with the special variable $?, and in your own scripts, you call exit followed by a number to report your verdict. One small but important habit. Send your error messages to stderr using the redirect &2. That way, when someone pipes your script's output somewhere, the errors still surface instead of getting swallowed. Exit codes tell you what happened, but they don't clean up after you. That's where trap comes in. You register a snippet of code, and bash promises to run it whenever the script exits, whether it finished cleanly, hit an error, or got killed mid-run. The classic pattern is right here. Make a tempdir with maketemp, then immediately trap an rf on exit. Now, no matter where the script dies, your temp files don't linger and pile up on disk. Exit isn't the only signal worth trapping, though it's the workhorse. ERR fires whenever a command fails under set, E, which makes it perfect for logging exactly where things went sideways. That Lenino trick will save you hours of debugging. INT catches Ctrl+C, so you can shut down gracefully instead of leaving half-written files behind. And here's the nice part. You can stack them. INT fires first, then exit runs your cleanup, giving you both a diagnostic trail and a tidy exit. Now, traps catch failures after they happen. But for anything destructive, you want a layer that prevents the failure in the first place. That's the dry run pattern. Notice the default here. Dry run starts at 1, and you have to explicitly pass. Apply to actually do the thing. The run wrapper either echoes what would happen or executes it. So that rf at the bottom? By default, it just tells you what it would delete. Safe by default, dangerous on demand. That's the right way around. Safe by default leads us straight into idempotency, the property that lets you run the same script twice or 20 times without breaking anything. Look at the left column. mkdir fails if the directory exists. Useradd fails if the user exists. Echo keeps appending the same line, and tar clobbers whatever's already unpacked. The right column fixes each one with a tiny guard. mkdir p, an ID check, a grep check, a directory test. One line, one flag, and suddenly the script stops lying to you on the second run. Idempotency handles repeated runs, but there's a sneakier problem: overlapping runs. Picture a cron job scheduled hourly that occasionally takes 90 minutes. Now you've got two copies stepping on each other's toes. The fix is flock. You open a file descriptor onto a lock file, then try to grab an exclusive lock with N, the non-blocking flag. If another instance already holds it, you exit quietly. Otherwise, you do the work, and the kernel releases the lock automatically when the script ends. And if you don't want to touch the script at all, the one-liner at the bottom wraps the whole thing right inside your cron tab. So let's pull all of these habits into one place. A skeleton you can paste at the top of every serious script. The shebang and description are obvious, but the real magic is set. Euo pipefail combined with a sane IFS, which together stop bash from silently swallowing errors. Then three tiny helpers. Log gives you timestamped output, dive fails loudly, and cleanup removes your temp directory. Notice the trap on exit. Whether the script finishes normally or crashes, your temp files get swept up. 8 lines, and suddenly your script stops lying to you. Even with that skeleton in place, scripts will still misbehave. And when they do, 3 tools will rescue you almost every time. Drop set X near the suspicious section and bash will echo every command with its variables fully expanded, so you see exactly what ran. If you'd rather not touch the file, bash x script.sh gives you the same trace from outside. And before you even run it, shellcheck will catch the quoting mistakes and unquoted variables your eyes keep skipping over. Now before we move on, let's talk about 3 habits that quietly turn solid scripts into liabilities. First, skipping set E because your script has always worked, until the day a network blip or a full disk proves otherwise. Make set euo pipefail a reflex at the top of every serious script. Second, sprinkling judge true everywhere to silence warnings. That doesn't fix bugs, it just hides them, so reserve it for one specific line with a comment explaining why. And third, no cleanup on interruption. Temp files linger, lock files stay locked. A single trap cleanup exit guarantees your cleanup runs, no matter how the script ends. So here's the whole lesson on a single page. Pin it above your desk if you have to. Set euo pipefail at the top, trap cleanup on exit, root errors to stir within 2, exit non-zero when things actually fail, use flock to prevent overlapping runs, and run shellcheck before you ship. 6 small habits. That's the entire gap between a hobby script and one that survives a production night. And if you want the even shorter version, here are the 5 mental shifts from this part. Bash defaults will quietly lie to you, so set euo pipefail makes the shell honest. Trap cleanup on exit so your script leaves no mess behind. Write things idempotently, mkdir p grep q before appending, so a second run never breaks the first. And let shellcheck catch what your eyes won't. 5 habits, and your scripts grow up. That wraps part 18, but the journey keeps going. Next up, we leave the world of single-host scripts and step into containers. Part 19 covers Docker basics, images, containers, volumes, and networks, the shipping standard for modern Linux apps. You're 18 of 24 and 3/4 of the way done. Take a breath, pour another coffee, and when you're ready, Docker run hello world. See you in the next one.